Hey, good morning. Let me go over the exam number 3. I'm not going to do in class because we need to keep going with thermal. Uh, just a second. Okay, force 300 newtons. This problem I did in class is an old one. Instead of a Johnny, I had Sally. But basically, you have a block. Could it be a bicycle? Could it be a car? Could it be a block? Could it be anything? But there is a forward pushing force of 300 newtons and friction, rolling friction is holding that down 100 newtons. Certainly you have normal force and gravity, but they will not count in the motion that is in the positive x direction. And it says that this action starts with a speed of 2 meters per second, and the road is leveled. And what happened 45 meters later, the mass is given. What is going to be its speed? So you could use laws of motion. You find acceleration because the initial velocity is required. Um, and you can use the criteria as we learned in chapter 4, chapter 5, using Newton's law to determine acceleration, and several of you did that. And and then with acceleration you can find the velocity. Um, but since it's an exam that is focusing on energy, then I will use energy consideration. In this particular case, the total work being equal to the change in kinetic energy. Change in kinetic energy. Right. So what is the work? The work is net force times displacement. What is the net force? Net force in x is 300 minus 100 times displacement, which is 45 meters. This is equal to the change in kinetic energy, which is half mass final velocity square minus half mass initial velocity square. Now the rest is just plugging equations, numbers in the equation. So 200 newtons times 45 meters is equal half the mass is 170, final velocity square, which we want to find, minus half mass times initial velocity square. And then we solve for that. So you have a toy that is attached to a string. The toy is whirled in a horizontal circular path on a frictionless tabletop. And what is the maximum tension? The maximum tension will be equivalent to the maximum speed of that toy. So here's the horizontal table, right? And then you have a circular path and you have a toy there. And you have this string attached and the toy goes with a certain speed. So in this case, gravity and normal force, they don't do anything to bring this toy into rotation. What it does is the string itself, the tension force. So what is the definition of centripetal acceleration? Centripetal acceleration is the net force responsible for rotating anything. So in this case, we have a toy, and the only force that is projected along the center of rotation is tension. So tension, and in this case, we want to find the maximum tension is the one that has the maximum speed is equal to mv squared over r, and then we can find the speed because the maximum tension is given 350 newtons. The mass is zero point 0.5. Some of you made mistakes, but I kind of overlook. Um, translated 0.5 in 50, right? So it's a, but this is obviously it's not a conceptual error. It's just an error of reading. Some of you did that. So mass times v squared over r, and then we can solve for v. Have one equation and one unknown. Ferris wheel. This I think this would be the most challenging problem in the exam that has to do with rotation. So we have a Ferris wheel that is a big circle that goes in a vertical, and the radius of it is 5 meters. Again, if there is rotation, there is centripetal acceleration, and it makes one revolution every 8 seconds. So this is the first part of the problem, that you have information given, but not directly, right? So you need velocity or speed to solve this problem, but speed is not given. What's given is revolution and time. So we have to derive speed from there. But let's keep reading. A person has a weight 670 Newton, is sitting in one of the benches attached to the rim, at the rim of the wheel. What is the apparent weight? And here is explained: the weight is the normal force exerted on her by the bench, on the person by the bench, of the person as she passed through the highest point. So you have something like this is a sitting thing, right? So you have a little chair and you have somebody sitting in there. So if you do your free body diagram here, normal force is a force the chair exerts on the person, and the person itself has a weight, right? So what is the definition of centripetal acceleration? Centripetal acceleration is the net of the available forces in the direction of motion, which is directly towards the center of rotation. So mg, and I'm writing the net force, mg minus the normal force is equal to your centripetal acceleration. That's what it is. And centripetal acceleration is mv squared over r. Centripetal force is mv squared over r. Mass times centripetal acceleration, which is v squared over r. So to find, mg minus fn, this is fn. So if you want to find the normal force, right? So the normal force shall be mg minus mv squared over r. And the rest is to plug numbers. So what is the mass? We don't have the mass. This is another complexity here. Mass is not given, but mass is equal to the weight, which is 670 newtons divided by g. mg is the weight. mg is equal to weight, the weight of that person, right? So if the weight is given, then we can solve for the mass. So the mass is 670 newtons divided by g, 9.8 meters per square second. And then we find our mass in kilograms. So I'm going to write the mass without calculating here, but you feel free to do that. And I will put these two terms outside a common parenthesis. So g minus v squared over r. So I could find now normal force. Since I know g, 9.8, I could find the normal force if I solve for v. So what is the information given for v? It is said that makes one revolution every 8 seconds. So which means it goes around and back to the same point 8 seconds. So an entire revolution is 2 pi radians, right? One revolution is equivalent to 2 pi radians. So one revolution every 8 seconds, one revolution every 8 seconds is 2 pi over 8 radians per second. This is the omega. But what is the definition of speed? Speed is omega r, and that shall be 2 pi over 8 radians per second times the radius 5 meters. And then we can solve for v, then we can plug here, and then we can divide by r, which is given 5 meters, and the problem solved. I'm solving quickly just to give the solution, but you should try to do slowly and with the steps. Through how many degrees, this is a problem that most of you got right, through how many degrees does 33 rotations per minute turntable rotate in 0.32 seconds? So 33 rotations per minute, RPM, is omega. And we have to translate that. We want to find degrees, right? But degrees are given either in radians or degrees. So we want it in degrees, so we have to convert this somehow to radians. So 33 rotation, each turn is 2 pi radians. Rotation per minute, so 2 pi radians every minute is 60 seconds. So then we converted omega from RPM to radians per second. That's the conversion factor. 33 times pi divided by 30 radians per second. I just simplified here. Okay. All right. So we have on omega, we want to find the angle. But what is the angle? Omega, if the motion is uniform, and some of you assumed there was some acceleration, but there is no acceleration in this problem, right? There is no change. So it's assumed this turntable is rotating with a constant omega. There is no stopping and go or not. There is no deceleration being provided here. So omega is the angle upon which the turntable rotates over time. Therefore, the total angle shall be omega times time, and then the rest is just to multiply up pi over 30 radians per second times 0.32 seconds. That will give you an angle. That will give an angle in radians. So if you want to convert this angle 2 degrees, and some students gave in radians, some students gave in degree, I overlooked for the fact that I was being asked in degrees. But if you want a complete resolution, you should convert that to radians. But again, if you had given your answer in radian, I accept it as correct. So you take this number, which is given in radians. You want to get rid of radians, and then what do? We multiply by we divide by pi radians and multiply by 180 degrees. So 180 degrees is pi radians, right? So we can get rid of that and then have our results in degrees. So you take that number, this is not u, it's a number, and then you divide that by pi and multiply that by 180, and then you have your results in degrees. I mean, when the bucket goes up, gravity pulls that down. It's like a resistant force, and the work done by gravity when the bucket is lifted is equal to the weight times the distance, but negative one, because it is going from down below way above. And but when it turns back and come down here, the work done by gravity is a positive work, right? Which is negative positive 35 times 3 joules. So the total, when you add those two, is 0. Which requires more work, increasing the car speed from 0 to 30 or from 50 to 60. So how do you know that? Well, we want to find work. So the definition of work is change in kinetic energy. So you have first to convert to be in the international system, which I recommend. You have first to convert these speeds to meters per second. Is stay in the safe side. So 1 mile per hour is 1 mile over this much seconds, right? And 1 mile is uh, 1 mile is 1 point somewhere around that 1600 meters, and then you have a conversion factor here. Okay. Um, so which means 30 miles per hour is the equivalent of 30 times this conversion factor, meters per second. And 50 miles per hour is 50 times this conversion factor. And 60 miles per hour is equal 60 times the same conversion factor. So if work is equal to the change in kinetic energy, the work from 0 to 30 shall be half mass of the car, which is, I know was not a given, and this 30 times 16, I don't have a calculator here, but you should have it. This much is square minus half m0 squared. So you have a number that depends on pretty much mass. When you do the same calculation for when the car goes to 50 to 60, your result is, because work is equal to the change in kinetic energy, this is the change in kinetic energy, is equal mass times final velocity squared. So it's this times this divided by this, but look here. So you have to square this quantity. I would say not a small amount of students, they did this. Well, the change in velocity is 6 minus 50. This is 10, right? And they did a square of 10. That's not it. It's the difference of the square of each of the speeds. Final minus initial, but square. This should be minus 50 times 16 or 36, and then you square that thing. That's the problem. So when you calculate this number and you compare with this number, you find that the work to go from 50 to 60 is bigger than the other one. We did this problem in class. We have energy at point A, energy at point C, and so you just do energy conservation. So at point A, you have potential energy, gravitational, and you also have kinetic energy at point A. And at point C, you do have also gravitational potential energy plus its kinetic energy. This is at C, this is at A. So it's a matter of mg times 200 plus, don't forget, some of you forgot the fact there was kinetic energy at part A. Half mv squared is equal mg vertical displacement at C plus half mvc squared. I mean, mass is a common factor to all these terms, and then you can eliminate that. And then G, then multiply 200 minus 160 times 2, right? Plus 20 squared is equal VC squared. In fact, plus 20 squared times 2, right? Times 2 here, because I have this factor 2. And then we can solve for VC. We can solve for that. So this is 400, this is 800, and then your G you have, and then the problem is solved. And pretty much that's it. This Tuesday, we will be doing a problem in thermal in the lab, and also don't forget to bring your PowerPoint and your project so we can work on it if there is time. All right. So see you on Tuesday.